we are going just to have a look at the system, so to say. So let's have a look at one of these things, okay? The models in our tool, they are still called like that. They are called the service logic graphs. They are graphs. You can analyze them like graphs. We are not going to discuss about that, but that means that it is a formal model. You can make mathematical proofs of correctness for this. And if you have ever heard about formal verification, if you have ever heard about model-driven testing or whatever, that's the kind of stuff that we are doing, okay? It doesn't touch you in this course, but we want to have models that somebody else is then able to analyze. So these are mathematical objects, apart from being drawings and apart from being executable, okay? They express the logic of the application, and they are using services. So they are service logic graphs, okay? How do they look like? Well, you have the nodes in the graphs. They are just instantiated components. So you have a library of components somewhere. You drag and drop them there. Now this instance, the one that is here and not there in the model, okay, even if they are two, they are different, okay. These are Sibs, so-called service-independent building blocks, okay. So we are going to talk about Sibs all the time, right? These are the basic components, so to say, the atomic ones, if you want, that we were talking about yesterday, before in the refinement. So all these are Sibs, all of them, okay. And, okay, for executability, only one can be the start Sib, and it is the one that it is underlined, okay. So you start here, not there, not there. Every time that you execute, you start here. Then there are branches. You have nodes and edges. The edges are basically branches. They are the outcome. They represent the outcome, so to say, of executing certain actions. Like, for instance, if it is a check whether a user is logged in, it can have two exits, true or false. If it was a PIN, it could be okay, not okay, correct, incorrect. If it was like in the telco, a routing SIB that basically says in the night call, transfer the call to this call center, in the morning to this call center, and in the afternoon to the other call center, you would have many branches, which would be just, the time windows that are selecting. You just have a test, what time is it? And then you basically decide where to route things depending on this. So you can be sensitive to the environment, which is very good for embedded systems, right? Then multiple outgoing edges, and this is important. Lots of people get it wrong, so please put it in your mind and remember it. Multiple outgoing edges represent alternatives. You can always be only in one SIB at a time. So either you're here, or you are there, but you're not in both. It is not a data flow, okay? It is not that you are producing this data that goes there and producing this data that goes there. It is not an architecture. It is not a gate level or register transfer level thinking where you are actually routing data between things. We are going to see the data later. This is just control flow. What happens next? It is a what happens next, and there can be only one thing that happens next. And here are decision points for the decision. Do I go this way or do I go that way? Okay, so you ask for a registration if the user is registered. If it is already registered, you go to the login. Otherwise, you go to the registration, right? It can be the case that several decisions, so to say, several outcomes go to the same place, so you can have more branches on a SIB. And you can have macros. It is again this green point. Okay, so you can open it up and find another graph in there. Okay, it will also have an initial point. So when you execute this, then you jump into this at this point, and then you execute it and come back. Okay, so it is a call, a normal call, okay, of a graph. And if you look at this thing, basically it is a small web application, web shop. If you have some articles in your cart, okay, in your Amazon web shop or whatever it is, and you want to get out, okay, then they check whether you are a logged in user, okay. If you're already logged in, they know who you are, they know your data, so you can they can just say, okay, the one-click approach, so to say, pay or don't pay, and then they show you the thank you message, and then you just basically clear the cart and then start the shipment. If you're not logged in, they ask you, are you a registered user, yes or no? If you are registered, then you just can log in. and that's this procedure, okay? Or you have to register yourself, and then you will log in, and then you will pay, and so on and so on, okay? So this is the way you can have actually many flows represented actually in one graph. If you know activity diagrams in UML, this is very similar to activity diagrams, a bit cleverer, but it is the way it is, right? Okay, so there are branches that basically in the model that say what is going in and what is going out. So what are these Sibs? You can have very different kinds of Sibs, okay? So these are all Sibs. You can have libraries of Sibs, and they are grouped in a way that makes sense, okay? There is also fork and join. They look a little bit different. So this is the real parallelism. If you want to have things that are really happening in parallel with threads, which is mostly not the case in your applications, then you need to have a fork Sib that basically says, okay, from one continuation I go to two, and then they have to come together again, because this is a synchronization point. So you cannot just execute one and then go there. This is not going to go forward until there is another OK that is coming from here after having executed that. And you can have also three-way parallelism and all this kind of stuff, right? But it is a sort of a spawn of a new thread, new process, and then you have to synchronize again. And then you can continue. Otherwise, you're stuck there forever, okay? So there are both big mistakes that people do. They understand the alternative here or there, okay, as a parallelism, and some people understand this, so to say, as an alternative. So please try to get that right, otherwise you're going to have problems, okay? If you look at the Sibs, now let's look at the ingredients. What are the Sibs? Well, they represent actually ready-made services. They are used like Lego blocks, so to say, to assemble a system. They should be configurable, they have parameters, and so they are reusable. You can, is the kind of functionality that you want to have many times in this application and that application, this version and that version. They should be executable, so there is real code behind, okay? Normally they are implemented as Java classes. We are discussing about implementation in different languages. That's not a problem. And they are organized in so-called Sib palettes, which are collections. So they used to be, in the old JVCs, common Sibs. And the common Sibs were just shipped to you together with the JVC. We also have some common Sibs, I think, in Dime. Or meanwhile, we have some, okay, that are doing the basic functionalities or whatever. So you get something, you don't have to create all the Sibs. There is already something there. They are documented. You can see different kinds of information or whatever. And if you want to look at the structure, what existed, so to say, in the previous JVC, okay, was like basic Sibs, like for instance, move a file, put an integer or whatever in the context in memory in a certain sense, or compare two numbers, match strings, evaluate conditions, okay, do nothing or so. About threads, sleep a thread or whatever, put a thread to sleep or whatever, repeat a loop, logging messages, locking elements, unlocking elements in case of synchronization and something like that, throwing exception, invoking another method in native code or whatever. So you see that there were many things that were actually already ready-made, and over time we are going to recreate them all in Dime, okay? But basically the idea is to have, these pieces of functionality that are executable and that they are available, okay? There were collection Sibs that were working with more complex data types like arrays, lists, stacks, maps, sets, sorted sets, okay? And then all the operations that you need in order to work with that. So you see this idea of abstract data type or thing with methods to work on that is already in the system, okay? GUI Sibs, like for instance, okay, beeping if something was happening, or showing a dialogue that is leading to a choice, so to branches, like a branching dialogue, or a confirmation dialogue. Yes, you did it, okay, or an input dialogue, or a message, or something like that, and so on and so on, okay. I/O Sibs of different kinds, like with files, copying, SCPing something, writing, exporting stuff, and so on and so on. And if you look at that, basically, I mean, there are some information that are typical of a Sib, and you're probably going to see it in Dime. There is no point in explaining you this because it is the old version. But basically, there is a standard template of what is a Sib and what kind of information you need to have in order for a Sib to be well designed, okay? So there is a guideline for this, okay, with labels, with parameters, with branches, with these kind of things, fixed and mutable. Okay, that's a different story. Okay, the important thing is that they used to have an icon that you could change, so you could just change the look and feel of everything, because what is important is not the way it looks, but the code and the characterization, so to say, at the interface, right? And so, for instance, the show branching dialog, so to say, would have had the text, which was this documentation. It shows a message in a pop-up dialog, and it features exactly one button for each branch configured during the Sibs, and so on. Huh? Or it had a user ID. It had a name, internal name, no, unique ID, sorry, a unique ID, because every Sib was actually uniquely defined. It had a name, and it had some other name that you could put on that in order to airbrush it in a certain sense, in order to become more understandable for the user in the context. It had some parameters like a title, like a message, and the type of the message, so you see that it is already becoming a little bit more programming language-like. And then it had the branches. So the fixed branches are the ones that were always there, okay? Cancel and error were always there, but you could add more, you know, like okay, or add more, right? And this is the way it looks like, okay? Show a dialog. And if you look at the example that we had before, it was actually appearing there, okay? So there are many users for this, and from the cartoons, so to say, you can have programming experts like you can have, which can be software engineers or developers, and basically these are the responsible for the software infrastructure. So they know the runtime environment, they know how to program the Sibs, and they do the programming of the Sibs. So you are going to have this role in the project. But there are other people, like for instance, application experts. Those who know about the concrete application, like in the healthcare domain, the nurses or the doctors or the administrators of a hospital or whatever, they should be still able to model the application in this environment if the Sibs exist. So they have to discuss with the programmers in order to have the Sibs programmed. But these people can themselves define Sibs that are virtual Sibs. Like, I would like to have something like this, and then they give it to you, please program it, okay? But they still can use this in the model. And we have to understand that they may not have any programming skills. So discussing with them about, I don't know, some complex union find type or something like that is completely out of discussion, right? Then there are some other people where basically there are the domain modeling experts. So they know about the domain. They are not responsible for an application, but they are the ones that know, okay, wait a second, we need a palette that has to do with data at rest. So what are the Sibs that have to do with data at rest? That's going to be different from the palette that has to do with data in motion. Okay, that's a different collection. So we should have somebody that is responsible for this. It should be somebody that is responsible for that. But there is somebody that is at a higher level that basically defines which palettes are needed, how they are named, who is going to do what. Okay, and this from the point of view of the infrastructure in this case, because we are talking about the C-cube chip, okay, or the application. Like for instance, okay, the Sibs that have to do with the patients, the Sibs that have to do with, I don't know, the accounting, the money, or the treatments or something like this, right? Or the management Sibs or something like that, right? So they organize and classify the Sibs and the SLGs. We don't have anybody like that. A couple of things are told to you already, but then you can have proposals for how to organize this in your own area of work there. And then there are end users, okay? We are not going to have them directly at the moment, but they would be the people that can still customize an application